Okay, and we are currently recording this session. All right, so as you guys know, this week is the last week of the marking period. So the 4 6 weeks ends on Friday. Okay, so basically, all grades need to be done by needs to be done by then. And so obviously, once we get everything done, we'll be ready to start spring break. Spring break starts next week. Hope you guys are just as excited about that as I am. A well-needed vacation. Anyway, on today, we are starting a new topic. Okay, and the topic that we are starting today is called harmonic motion. And what harmonic motion deals with is it's a branch of physics that deals with modeling processes that repeat themselves. Okay, so in our everyday lives, we see things all the time that repeat themselves over and over and over again. So harmonic motion deals with modeling that process mathematically. In other words, giving a mathematical description to physical events in nature. Um, and so let me click on um, my Schoology screen here. Just kind of show you guys what to expect for today. So we are in fifth period. I just realized I hadn't made this. I didn't turn this assignment on for you guys to see it. Let me go ahead and do that now. So go to 4 6 weeks. We're in the week of March 8th through the 12th because it's March 9th. Today is a Tuesday. So as I said, we're talking about harmonic motion today. We're going to go over the notes together as a class, look at a few example problems, and then I'm going to get started with a few of these problems on the actual assignment for you guys to turn in. And of course, you're going to complete the rest of them on your own. Okay, let me go ahead and make this visible to you guys just to be sure. Yes, submissions are enabled. Put the due date. Okay. All right, you guys should be able to see this assignment pop up on your main screen now, because I made it visible on your main screen. Okay, but this is what we're going to be talking about today: harmonic motion. So, as I stated, harmonic motion is a subtopic in physics that deals with processes that repeat themselves. Let me give you guys a simple example of what I mean by this. Processes that repeat themselves. Trying to get ready to play these video clips here. Okay. So here's what I mean when I talk about a process that repeats itself. In your everyday life, some of you guys are familiar with springs. Springs are everywhere. You guys are familiar with springs. In fact, you might have seen springs that make up the shocks on your car. So here's an example of a simple spring right here. Like imagine that we have a wooden block here connected to this spring, and imagine someone takes this block and then they pull it, and then they release it, and the spring and the block just bounces back and forth, back and forth. Guys, this is an example of harmonic motion because notice this process is just repeating itself. It's repeating itself over and over and over again. It's just swaying back and forth continuously. And of course, assuming here that there's no friction here to sort of slow the system down, this system, or in other words, this block and spring, would just keep swaying back and forth. It just keep going like that over and over and over again. So, like I said, this is an example of simple harmonic motion. And what we're going to be talking about today, ways of analyzing this process mathematically. And of course, in your everyday life, some of you guys have probably seen springs that sway with a much greater frequency than this. For example, you might have, seen a spring where like you pull it back and you release it, and it goes like boing, yoing, 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 yoing. So like you've seen springs that probably have swayed more than this, or I should say, sway with a greater frequency. But the point is the same: is that we're still dealing with harmonic motion because the process keeps repeating itself. Uh, Now here we're talking about, well, here these bars kind of show us kinetic energy, potential energy, and the total energy. But we're not going to get into that today. We're not going to talk about kinetic energy and potential energy of a spring system. That's more for students in AP Physics. I just want to focus on analyzing the system itself. Um, here's another example of simple harmonic motion. Okay. Many of you guys may be familiar with grandfather clocks, or pendulums. So if you guys ever seen like a pendulum that's kind of swings back and forth like this, or a grandfather clock, this is the example of harmonic motion. Again, it's a process that repeats itself over and over again. It's kind of like if you're, uh, you're in the park and you're on one of the, you know, swing sets, and you're just swaying back and forth, back and forth. That's an example of harmonic motion, something that repeats itself over and over and over again. Um, we're not going to talk too much about velocity on today. We're just going to just sort of look at the simplest ways to analyze this process mathematically. But anyway, that's what I mean when I talk about harmonic motion. I'm talking about processes that repeat themselves over and over and over again. It is important that you guys know how to analyze these situations mathematically, because think about it, guys. Um, Repetitive motion happens all the time in nature. I mean, look at weather patterns. Weather patterns, they oscillate. They repeat themselves. If you look at the atoms that make up the if you look at the atoms that make up the particles of your body, they oscillate. They bounce back and forward. So my point is that because this process happens all the time in nature, we need to know how to describe this process mathematically, and that's what we're going to focus on when we focus on harmonic motion today. If you guys have not filled out the attendance form, go ahead and click on that and get that filled out now. Okay, so let's go back to Schoology. Okay, like I said, I want to go over a few things with the notes with you all. I'm going to open up this PDF file in Kami so that I can write on it. Okay, okay, so if you look at Schoology, I've given some notes to you guys, and you're going to use these notes to help you with your assignment. I want to go over a few of the definitions. I just talked about what harmonic motion is. It's any motion that is repetitive, something that's doing the same thing over and over again. And so here's some examples of harmonic motion: pendulums, bouncing springs, wheels, waves. So these are all examples of harmonic motion processes that repeat themselves. Now, whenever we're talking about harmonic motion, there's some terms you guys need to be aware of. Um, um, I want to look at these two terms right here, period and frequency. These are probably the most two important terms that we're going to talk about on today. Period means the length of time for one cycle. So, for example, if you have a spring that's swaying back and forth, and that process keeps repeating itself, imagine that you had a stopwatch, and you looked at your stopwatch, and you looked at the amount of time in seconds it takes for that spring to go one cycle. That is what is known as the period. So in other words, period just refers to how long it takes for an object to go one cycle, assuming it's moving in a repetitive fashion. So period means how long, and that is typically measured in seconds. Frequency, on the other hand, is by definition the number of cycles per second. In other words, how often the object is swaying back and forward. So hopefully everybody got that. So period is how long there is in one cycle. In other words, how many seconds there is in one cycle. But frequency means the number of cycles per second, how often that your object is swaying back and forward. One of the things that's important to know is that these two terms, they are reciprocals of each other, meaning that like if you know one, you can easily calculate the other by just using these equations here. And in just a moment, I'm going to show you guys how to do that. But first, let me show you guys how to find period and frequency conceptually. So let me open up this video clip here. Okay, I want you guys to notice something here. We have a Ferris wheel, and this Ferris wheel, you guys obviously have seen Ferris wheels before. They just kind of just move in move in a circle like this over and over again. So guys, this is an example of repetitive motion. This is an example of harmonic motion because notice this process is just repeating itself over and over again. So the question is, how can we figure out what is the period of this Ferris wheel? How can we figure this out? Well, guys, you guys can easily figure out the period easily if you have a stopwatch. And in fact, if you have a stopwatch right now on your cell phone, I would recommend that you guys do this with me. So I'm going to pull out my cell phone, and I'm going to open up the stopwatch app on my cell phone, and I'm going to right now figure out what is the period of this Ferris wheel. So that's what I'm going to do right now. Figure out what is the period of the Ferris wheel. So remember what I said what period is. Period just refers to how long it takes for the Ferris wheel to go one cycle. Okay, that's what period refers to. How long it takes the Ferris wheel to go one cycle. Okay, so guys, look at this box in yellow. Here's what we're going to do. Okay, we're going to look at that box in yellow, and when it comes to the top of the path, we're going to start our stopwatches. Okay. And then when it comes all the way back around again, we're going to stop our stopwatches. Okay, so let's go ahead and do that now. So as soon as that yellow box, okay, I'm going to hit start. Hey, because notice it's at the top of the path. And notice my stopwatch is going. As soon as that yellow box comes right back to the top again, I'm going to stop my stopwatch. And stop. Okay. So guys, on my stopwatch, it shows me that my period was 13.1 seconds. So I'm going to write that down. My period was equal to 13.1 seconds. Okay. So guys, that's what I mean when I say period. Period just refers to the time it takes for that object or that system to go one cycle. So in this case, the yellow box here. So if you actually pulled out your stopwatch and you looked at it, how long it takes for the yellow box to start here, go all the way around and come back here, that took 13.1 seconds. Okay, so that is our period. Okay. Now, guys, as a general rule, anytime you know period, you can easily figure out frequency by just taking 1 and dividing by the period. So I'm going to write that down now. So guys, in order to find frequency, because these two things are reciprocals of each other, you can easily find frequency by just taking 1 and dividing by 13.1. In other words, you're taking 1 and dividing by whatever we got for our period. Okay. When I do that, guys, if I take 1 and divide it by 13.1, so I'm putting in my calculator to see what I get. So 1 divided by 13.1, okay, that gives me 0.76. I'm sorry, 0.076. 0.076. And by the way, guys, your units for frequency, we call that the hertz. So 0.076 hertz is my frequency of my Ferris wheel. Okay. So guys, that's how you figure out period, and that's how you figure out frequency. Again, the period was 13.1 seconds. The frequency was 0.076 hertz. Okay. So keep that in mind because you guys are going to be doing that a lot on this assignment. Remember what these terms means. Period means how long it takes for this this top Ferris wheel here to go one cycle. So how long it takes to go one cycle, whereas frequency means the number of cycles are in 1 second for this Ferris wheel. Okay, so just keep that in mind. All right. So let me close the screen here. Okay, so with that said, let us go back to these notes here. Okay, so guys, remember what I said that whenever we have processes that are repeating themselves over and over again, we want to know how to model those processes mathematically. The way that we do that is that we use a function on a graph to help us visualize what's happening mathematically. It's either a sinusoid or cosinusoid function, and then we just plot it out on a graph. So basically, it looks like waves on a graph, and these things right here actually model real-world processes that repeat themselves. So whenever you guys are looking at a graph of harmonic motion, there's a few things you guys need to be aware of. One term I want you guys to know is what is known as the amplitude of the graph. Okay. Well, what does amplitude means? Amplitude means how far the graph goes away from the center. So in other words, it's the distance from the midpoint. So for example, guys, look at this graph right here. How do I know the amplitude of this particular graph? Well, what you would want to do first, you would want to look at the midpoint of the wave. So the total wave from minimum to maximum is the distance between this point and this point. So the midpoint there, the midpoint will be right here. The midpoint of that wave will be right here. Okay. And obviously the very top of the wave, the height of the wave is right here. Okay. So guys, that distance right there from the top to the midpoint, that distance there is sort of referred to as the amplitude. So in this case right here, the amplitude is 4 centimeters. Okay, the amplitude is 4 centimeters because we notice if we look at the y component of our graph, we can see that the total height from here to here is 4 centimeters. So guys, that's how you can figure out the amplitude of a graph that is visualizing harmonic motion. There's two ways you can find amplitude. You can either look at the distance from the midpoint to the top, or you look at or you can either look at the distance from the midpoint to the bottom. Okay. Both those methods will allow you to figure out what amplitude is. Okay. So that's what amplitude is. Amplitude just means the distance from the center out to either the maximum or the minimum. So distance from the midpoint, basically, is the amplitude. Okay. Also, guys, whenever you are whenever you are looking at a mathematical graph of harmonic motion, you guys need to know how to be able to count the number of cycles that appears in that graph. Okay, so the way you do that, you just look at the graph and you just look at how many times the curve repeats itself. So, for example, notice here, like look at this graph here. Notice how the graph starts here, it goes down, it comes up, and it goes back down again. And if we stop there, that represents one cycle. Uh, how do we know that represents one cycle? Because after that, notice how the curve repeats itself. Okay, goes down, goes up, and it comes back down again. Okay, so notice that curved line in red is an exact replica of the curved line in blue. So this part of the graph looks exactly the same as this part of the graph. So for this particular graph right here, we will say that we have two cycles represented on this graph. Two cycles. So in other words, the curve repeated itself 2 times. Okay. So guys, keep that in mind. So cycle just means one repetition of motion on the graph. Okay. So we clearly see that this curved line in blue, that's one cycle, and the curved line in red, that's 2 cycles. So if you want to know how many cycles appear on a graph, just look at how many times that curve repeats itself. Again, the red line is an exact clone of the curved blue line. Okay. Okay. Now, guys, let us look at some actual examples. That's what I want to do with you guys. Look at some actual examples here. Okay. So I want to look at this situation right here first, and these problems here in this box where it says convert from period to frequency. Okay. So here, okay. So notice we're given various period values. Remember, period is always in seconds because it represents the time in one cycle. And it says to figure out the frequency from these periods. Remember what I told you guys, and I'm going to write this down. Frequency by definition is equal to 1 divided by the period. So here, guys, if our period here is 1 second, 1 divided by 1 gives us 1 hertz. So our frequency here is 1 hertz. Okay, let's keep going. Here our period is 0.1 second. So in order to find out your frequency, you would just do 1 divided by 0.1. So 1 divided by 0.1. If you put that in your calculator, you will find that it's equal to 10 hertz. Remember, the standard unit for frequency is in hertz. Okay. What about here, guys? If we have a period of 0.5 seconds, what is the frequency there? So what is 1 divided by 0.5? 1 divided by 0.5 is equal to 2 hertz. Okay. So everybody got that? It's really simple to calculate frequency if you know period. You just do 1 divided by the period. Okay. So what about here? So here, our period is 4 seconds. So if our period is 4 seconds, that means our frequency will have to be 1 divided by 4. So in other words, it's 0.25 hertz. Okay. Here, our period is 2 seconds. So our frequency would have to be 1 divided by 2, meaning it's 0.5 hertz. Okay. What about here? What if I have a period of 0.25 seconds? What is the frequency there? So 1 divided by 0.25, you put it in your calculator, you will get 4 hertz. Okay. So hopefully everybody got that. Anytime you want to find frequency and you know the period, you just do 1 divided by the period to give you your frequency. Okay, so everybody got that? So with that stated, let's go over here and look at this column right here. And this column right here says calculate the frequency from the period. So notice we're going backwards compared to what we just did before. Here they give us our frequency in hertz, and they ask us to find the period in seconds. Okay, so the way we do that, okay, so if we have 1 hertz, remember 1 divided by 1 will be just 1 second. Okay. So guys, that's how you find period if you know the frequency. Let me write that down. Period is just equal to 1 divided by the frequency, right? Since period and frequency are reciprocals of each other, if you just do 1 divided by the other, you can easily figure out what the quantity is. Okay. So here we see that here our frequency is 2 hertz. So if our frequency is 2 hertz, what is our period? Well, what is 1 divided by 2? 1 divided by 2 is 0.5. So it will be 0.5 seconds. So 0.5 seconds is our period. Okay, let's move on to the next one. What do we have a frequency of 0.5 hertz? Okay, so 0.5 hertz, if I do 1 divided by 0.5, that would be 2 seconds. Okay. It would be 2 seconds. Okay, 1 divided by 0.5 is 2 seconds. Okay, so let's keep going. What do we have a frequency of 10 hertz? So 1 divided by 10 gives us our period. So in that case, our period would be 0.1 seconds. Okay. A frequency of 5 hertz. So 1 divided by 5 gives us 0.2 seconds. Okay. What do we have a frequency of 0.1 hertz? So 1 divided by 0.1, that is equivalent to 10 seconds. Okay. So hopefully everybody got that. That's how you calculate period. Okay, if you know frequency in hertz, you can easily calculate period by doing 1 divided by the frequency. Okay. So everybody got that? So frequency is equal to 1 divided by period. Period is equal to 1 divided by frequency. Those two terms, they're reciprocals of each other. All right. There's only like 2 more of these sections that I want to complete here before I'm done looking over these notes. On the assignment, it's very important that you guys know how to look at a particular graph and you know how to recognize what is the period, frequency, and amplitude from that graph. And also it's important that you guys recognize the number of cycles that is represented on that graph. So for example, look at this graph right here. Okay. So how many cycles here are represented on this graph? So remember I told you guys, in order to figure out the number of cycles, you just count how many times the graph repeats itself. So look at this this curved line here. So notice how it starts here, goes like this, stops, and then after that point, it starts to repeat itself. So this is the next cycle. Okay, so the line in blue is my first cycle. The line in red is my second cycle, but notice it keeps repeating itself. So here's another cycle here. And then here's another cycle here. Okay. So notice here, I have a total of 4 complete cycles. Okay. Remember guys, one cycle just represents one section of harmonic motion on the graph. And then each time the curved line on the graph repeats itself, we get another cycle. So this is 1 cycle, 2 cycles, 3 cycles, 4 cycles. Okay, so this particular graph right here repeats itself 4 times. So if you have a question that asks you the number of complete cycles, in this case right here, you will put 4, right? Because it repeats itself a total of 4 times. What if I want to know the period, the frequency, and the amplitude that's represented on that graph? Okay. Well, guys, you can easily figure out the period by looking at the number of seconds in one cycle, right? Because that's what period means, number of seconds in one cycle. Okay. Now, guys, look at your x-axis here. So if you look on your x-axis, notice how we have time in seconds along the x-axis. So, guys, if we look at one cycle and only one cycle, so the length from here to here, that's obviously one cycle. If we look at the amount of time in that one cycle, we read that it says there's 0.15 seconds in one cycle. So that means the period here would just be 0.5 seconds. Okay. So you guys clearly see that there are 0.5 seconds in this one cycle. So that's why I put 0.5 seconds for my period. And remember, guys, I told you guys how to find frequency. Frequency is just 1 divided by the period. So if you take 1 and divide it by 0.5, that gives you a frequency of 2 hertz. Okay. So everybody got that? What is our amplitude? Remember what I said? Amplitude measures the height of the wave. Well, the height of the wave as measured from the midpoint. Okay. So if we look at this graph here, notice here this is our midpoint. Okay. And notice here this is the very top. Okay. Okay. So guys, what is the distance between the midpoint and the very top? Okay, so off to the side, if you look on your y-axis, we see the distance in centimeters. So from this point to this point, that is 2 centimeters. So 2 centimeters will be our amplitude. So 2 centimeters would be our amplitude. Okay. So everybody got that? Let us look at one more example. Let us look at this example right here. Okay. First off, guys, how many cycles of harmonic motions do we have here? How many cycles of harmonic motion do we have here? So, well, let's see. Let's just count how many times the graph repeats itself. So you notice the curve starts here and it goes like this. Okay. You see that right there, that's one cycle. How do I know that's one cycle? Because immediately after this point right here, notice how the curve starts to repeat itself. So that right there, that's 2 cycles. And notice here, we have another cycle here, but that's not a full cycle. I would say that's like 1/3 of a cycle there. So in this case right here, number of cycles right here, we will have, I would say we have 2 1/3 cycles, right? 2 1/3 cycles, right? So sometimes I've seen it where you have like 2.5 cycles or 2 1/4 cycles. In this case, I would say this is somewhere around 2 1/3, or somewhere around there. Okay. What about the period, guys? What is our period? Well, the period here, remember, period represents the time in one cycle. So if you look at between this point and this point, that would be indicative of one cycle. And so here, the period is 3 seconds for that one cycle. So here our period is 3 seconds. And the frequency would be 1 divided by 3. So 1 divided by 3, which is equivalent to 0.333 hertz. Okay. And then lastly, what is the amplitude here? Well, looks like I already had amplitude written down. Amplitude is 3 centimeters here. And I want you guys to see why the amplitude is 3 centimeters. Because remember what I said what the amplitude is? The amplitude is measured from the midpoint. If you look at this graph here, so notice this right here, this is, the minimum point of the graph. This right here, this is the maximum point of the graph. So where's the midpoint? Well, that should be easy to find. If we count from here to here, this is 1, 2, 3, 4, 5, 6 centimeters. So if this total distance here is 6 centimeters, that means the midpoint right here will have to be right here at this point, because you would count from here to here 3 centimeters to get to the midpoint. So since the distance from here to our midpoint is 3 centimeters, that is our amplitude. Our amplitude is 3 centimeters. And notice that's what I have written down here. That the amplitude is 3 centimeters. Okay, any questions on anything regarding these notes that are currently in Schoology? Any questions? Okay, if there are no questions, the last thing that I want to do with you guys today, I just want to look at a few of these problems with you all on the assignment that is currently in Schoology. So if we look at this assignment here, there's some math problems here, and there's also some definitions. I'm just going to go over a few of the math problems with you guys. So a lot of these you guys should be able to do yourselves. Okay. Look at this question right here. I want you all to see this right here. It says a pendulum takes 10 seconds to complete 2 cycles. What is its period? So guys, this is actually easy to calculate because remember what I said. Think of the definition of period. The definition of period represents the number of seconds in one cycle. So in other words, is cycles divided by seconds. I'm sorry, excuse me. I said that wrong. Is seconds divided by cycles. Let me make sure I say that again correctly. Period just means the number of seconds in one cycle. So if you take, I'm going to write this equation down here. So anytime you want to find period, I'm going to write this down. Period is equal to the number of seconds divided by the number of cycles. So for this case right here, you would take 10, because we have 10 seconds, divided by 2 cycles. What is 10 divided by 2? That actually gives us 5 seconds for our answer. So this right here would be 5 seconds. So hopefully you guys got that. Anytime you want to figure out what period is, it's just the number of seconds divided by the number of cycles. Okay. So let's look at another one of these problems. Okay. So look at this problem right here. It says a pendulum takes 10 seconds to complete 2 cycles. What is its frequency? Now, guys, frequency, remember I said it is the reciprocal of period. If period means the number of cycles divided by the number of, excuse me, I keep saying this wrong in my head. If period means the number of seconds divided by the number of cycles, frequency would be the reciprocal of that. It would be the number of cycles divided by the number of seconds. So I'm going to write it down. Frequency is equal to the number of cycles divided by the number of seconds. Okay. So in this case right here, we have 2 cycles divided by 10 seconds. So what is 2 divided by 5? So 2 divided by 10, 2 divided by 10, that is equal to 0.2 hertz. So 2 divided by 10 is equal to 0.2 hertz. So our answer here will be 0.2 hertz. Okay. So everybody got that? The equation for period will be the number of seconds divided by the number of cycles. Frequency will be the reciprocal of that. It's the number of cycles divided by the number of seconds. So just want that to be clear to you guys. Okay. Right here on this graph right here, when it says where is the equilibrium position, guys, know what equilibrium position means. Equilibrium position just means what is the midpoint. You notice the midpoint of this graph right here, the midpoint of the wave is exactly at 0 centimeters here. So you just put 0 centimeters here. Okay. The rest of this you guys should be able to do by yourselves. Are there any final questions for me? So guys, I am going to leave the Zoom call open up until like somewhere around 9:10 when this 5th period class is over, just in case you guys have any questions while working on the assignment. But guys, if you do not have any questions for me at the moment, you guys are free to go. I'm going to put the link to the attendance form in the chat box for you guys that did not get to fill that out. So please click on that and fill out the attendance form if you have not done so. Bye guys, and I hope you all have a good one.